Okay, so this is the section 3 of Mathematics of Finance, future value of annuity and present value or sinking funds. So the difference between simple interest and compound interest and future value of annuity is, in simple interest we deposit our principal amount once and we withdraw our interest. In compound interest, what we do, we invest our principal amount once and we don't withdraw our interest and we reinvest our interest. And one more thing to differentiate between simple interest and compound interest is, in compounding interest you will be given compounded periods, and now in future value of annuity we don't invest our principal amount once, but there would be a sequence of equal periodic payments. A very good example of this, like you can take the monthly salaries. If you have an account in a bank and your employer is sending your salaries every month into your account, now your account will have a sequence of equal periodic payments. So these are called annuities. You will get interest on those annuities, on your principal, on your deposits, and you will reinvest your deposit as well. And one more thing, you will have compounding period in future value of annuity as well. Now the question is how to differentiate between compound interest and future value of annuity is, in compound interest we will have our principal amount once, like we will deposit our principal amount once, but in annuities we have a sequence of equal periodic payments. Now when you will solve different examples, this is the only thing which we will identify, that how do we know that this is a problem of compound interest or this is a problem of future value of annuities. Now the students will able to compute the future value of annuity, the sinking funds, and approximate interest of annuities. So here is a simple derivation of the annuities. We don't need to get into this. We can directly jump into the formula, which is future value of annuity equals to PMT. PMT is a sequence of equal periodic payments. Before we were denoting our principal amount by P, before we were denoting our principal amount by P, but now we will denote a sequence of equal periodic payments by PMT. FV is the future value, I is the interest rate, and again point to be noted that I equals to R over M. Now what is R? You know, R is the interest rate and M is the compounding period. Similarly, N equals to R T cross M. M is compounding period, T is number of years. Now here you can see I will explain this example in detail in order to let you know what is the difference between compound interest and future value of annuity. Suppose $1,000 investment payment is made at the end of each quarter. Now this word end of each quarter means that we are depositing $1,000 after every quarter. So it is not once, and the money is in the account is compounded quarterly. Compounded quarterly tells us that M equals to 4 at the rate of 6.5%. So R is 6.5% for 15 years. So T is 15. How much is in the account after 15 years? So future value of annuity. So after 15 years, what would be in your account? Here one more thing I would like to mention. We will use it later in order to differentiate between future value of annuity and present value of annuity. If you reread this example once again, it will give you a perception that after 15 years you will have a lump sum amount in your account. Like how much is in the account after 15 years? When you are dealing with such type of situation, that when you realize that after prescribed period, like after 15 years, you will have a lump sum amount in your account, and that is why we know that this is a future value of annuity. And if I change it, how I can change same problem into compound interest? By removing simply this sentence. Suppose $1,000 payment is made into the account. If I remove these lines, that at the end of each quarter and the money in the account, suppose a dollar thousand suppose a $1,000 payment is made in the account is compounded quarterly. If I remove these lines, then it would be a problem of compound interest. And if I add these lines, like we are making a sequence of equal periodic payments, then it would be a problem of future value of annuity. Now the rest of the things are very simple. You know the formula, you can substitute the values into the formula and you can get the answer, like future value of annuity equals to 100,336.68. Okay, so I think we have explained everything in detail about this problem. Now let's jump into another problem. For example, how much interest was earned over the 15-year period? This is very tricky. In simple interest, sorry, in future value of annuity, how do we calculate the interest? Like your future value minus the amount which you deposit, pmt times m cross t. Like how many sequence of equal periodic payments did you make? Like pmt was pmt was 1000, so the interest will be, future value was 100,336.68 minus, we were depositing $1,000 after every quarter. So there were 4 quarters in 1 year, and we were doing this up till 15 years. This is the amount which we deposited, and this is the amount which we got after 15 years. So the interest is 40,336.68. Okay, so here definition of sinking fund. In case of sinking funds, in short, it is not a big deal, or it is not something out of the box. We can simply, what does it mean by sinking fund? Means that we need to find pmt. Simple as that. The formula of future value is future value equals to pmt times 1 minus I raised to power n minus 1 divided by I. If you take the cross multiplication, if you take I to the other side, if you take the cross multiplication, it will become I times future value. You can take the cross multiplication, this will go down, 1 minus I raised to power n minus 1 equals to pmt. So this is your so-called sinking fund. Okay, you can see this is the sinking fund. Okay, now here we solve this example related to the sinking fund. How much must Harry save each month in order to buy a new car for $12,000 in 3 years? How much Harry have have to save each month in order to buy a new car? Like in future, Harry wants $12,000 in 3 years at the rate of 6% compounded monthly. So m is 12. How much must Harry save each month means that how much equal of sequence periodic payments would be. So you need to find pmt. So from here your interest will be I equals to r by n. I is 6% over 12, which is 0.5% is your I. Now you can substitute the values into the formula and you can get pmt. Okay. Here we solve one more example. Mr. Ray has deposited $150 per month. Now this per month means that this word per, even this word per is indicating us that we are depositing $150 every month. So this is a problem of sequence of equal periodic payments. From this first line we came to know that this is a problem of annuity. Now we will read it further to know that is it a future value of annuity or present value of annuity. Into an ordinary annuity, if I remove this word annuity, after 14 years, so t is 14, the annuity is worth, after 14 years its worth is 85,000. What annual rate compounded monthly? We need to find r. Compounded monthly means m is 12. Has his annuity earned during the 14 years? So we need to find r. So this is a problem of future value of annuity. After 14 years he will have 85,000. So he will have lump sum amount after 14 years. Now you can substitute the values into the formula and you can easily get the PMT. Here, you can skip this example for the time being. For your PPT, we will discuss it in live tutorial because I need your questions on that problem. If you can understand it, that is more than good, and if not, then we can discuss it in the live tutorial. So that was your future value of annuity.